All right, hey guys. 8.2, we're continuing to solve systems of equations. This time we're solving by elimination. Elimination is my favorite way to solve a system of equation. I think it's the most straightforward approach. And it just makes the most sense to me. When you're doing elimination method, sometimes you're going to have to multiply equations by a number. You can multiply by any number, whole number, fraction, decimal, as long as you aren't multiplying by 0. It doesn't matter what you have to multiply by. But basically what you want is that you want one of your variables to be the same number, just different signs. So like a positive 2 and a negative 2. Once you have one of your variables set up like that, you're going to add the equations together, because what that's going to do is it's going to eliminate that variable. It's going to add to 0, or it's going to cancel out, which leaves you with only one variable left to solve for. So we solve for that last variable, and then we're going to take that answer and we're going to substitute it in to one of our original equations to solve for that other variable. And as always, we always write our final answer as an ordered pair. So we're going to look at a couple of examples together and solve these through elimination. And again, I don't want you to panic, because at the end of the day, once we've learned all three of these methods, we've already done graphing and substitution. Once we get through elimination, it's up to you which way you want to solve these systems. I'm not going to make you solve them one way or another on a test. I just want you to be able to solve them. Okay, so I started these nice and easy. So remember, we want one of our variables to be the same number, the same coefficient, just positive and negative. So if we look at number 1, x minus y equals 4 and x plus y equals 12. The y's, it's a negative 1 and a positive 1. Okay, so we can just go ahead and add those two equations together, because they're already going to add to 0. So x plus x is going to give me 2x. Negative y plus y is 0. 4 plus 12 is 16. I'm going to solve for x by dividing by 2, which is going to give me 8. Now, it doesn't matter which equation we plug that 8 into. I'm going to bring this back and plug it into the bottom equation. So 8 plus y equals 12. I'm going to subtract my 8 on both sides, which is going to give me 4 for y. And remember, as always, we just write that answer as an ordered pair. I hope that was pretty straightforward for you. I would encourage you to go ahead and try number 2 on your own. Again, I gave you a more simple one. Your x's, it's already a positive 1 and a negative 1, so you don't have to multiply by anything. So pause the video, work this one out on your own, and then come back and check your answer with mine. Okay, so since our x's are already the same number, just opposite signs, we're going to add those equations together. Negative x plus x is 0. 2y plus 6y is 8y. 12 plus 20 is 32. So I'm going to divide by 8. 32 divided by 8 leaves me with 4 for x. It doesn't matter which one we plug into. I'm just going to go ahead and plug into the first one this time, just to make things a little bit different. So I'm plugging that 4 in for y. So 2 times 4 is 8. I'm going to subtract that 8. I've got negative x equals 4. And then I want a positive. So I divide by a negative to get a positive x, which gives me negative 4 for x. And as always, we're just writing that ordered pair. Okay, so we're going to add just a slight difficulty to these next two problems. They're not necessarily going to already be able to be added together, but in number 3, we've got 2a plus 5b equals 3, 2a plus b equals 9. So we already have a 2a and a 2a. So the only thing that one of those needs is to be a negative. It doesn't matter which one you do. I'm going to go ahead and I'm going to multiply that second equation by -1. So I'm going to leave my first equation alone. 2a plus 5b equals 3. I'm multiplying each part of that second equation by -1. So -2a minus b equals -9. Now, it's important that you multiply every piece. If you don't multiply every piece, you're not going to get the right answer. So I'm just adding, I'm just adding those two together. So 2a plus -2a is 0. 5b plus -b is 4b. 3 plus a -9 is -6. I'm going to divide. So -6 over 4 is going to simplify down to -3 over 2. And then from there, I am going to plug that into one of my other equations. I'm going to plug that into my original second equation. 2a minus 3/2 equals 9. I'm going to add 3/2 to both sides, which is going to give me 21 over 2. And I'm going to divide by 2 on both sides, which is going to give me 21 over 4. Now, when you don't have x and y, you tend to just put the ordered pair in alphabetical order. So A is going to go first, B is going to go second. Okay, so same thing for number 4. We're just looking for something that we can easily cancel out. If you feel confident in trying number 4 on your own, go ahead and pause the video and try it on your own. If not, that's fine. Just keep watching. So always look for the easiest one that you can do. We have a -x and a positive 2x. So we already have the negative positive. If you already have the negative positive and it's not going to be a chore getting them to be the same number, I would go with that. So this is a -1 in front of that x. So to get that to be a -2, which would end up making those add to 0, we just have to multiply that first equation by 2. Remember, we're multiplying each part. So we end up with -2x plus 4y equals 12. We're going to add that to the original second equation. We're not changing that at all. -2x plus 2x is 0. 4y plus 5y is 9y. 12 plus 6 is 18. And then we divide by our 9. We end up with 2 for y. So we're just going to go back through and we're going to plug that into one of our equations. It does not matter which one. Okay. We'll just change it up a little bit and go with the second one this time. So 2x plus 5 times 2 equals 6. 5 times 2 is 10. I'm going to subtract my 10 on both sides and divide by 2, which is going to give me -2 for x. And as always, we're just writing that final answer as an ordered pair. So -2, 2. And again, if you're not ever sure if you're getting the right answer, if you plug that ordered pair in for x and y in both equations, you should get two true equations. So you should get something like 5 equals 5, 10 equals 10. Both sides of the equal sign should be equal to each other. Okay, we're getting a little bit harder. 4x plus 5y equals 7. 6x minus 2y equals negative 18. These are turning into cases where we're going to have to multiply both equations. Again, it does not matter which variable you decide to cancel out. If you have an easier option, go with the easier option. Okay, so we've got 4x and 6x, 5y and negative 2y. Since our y's have a positive and a negative already, I'm going to choose to eliminate those. So if all else fails, when you're doing these, it will never be wrong to multiply the first equation by whatever number's in front of your variable in the second equation, and to multiply your second equation by whatever number is in front of your variable in the first equation. So for example, it's never going to be wrong to say, okay, I have a 2 in front of my y in this second equation, so I'm going to multiply my first equation by 2. And I have a 5 in front of my y in the first equation, so I'm going to multiply my second equation by 5. There might be a smaller number that you could multiply by, but that's never going to be wrong to do it that way. Okay, so we multiply everything in the first equation by 2, which is going to give us 8x plus 10y equals 14. We multiply everything in the second equation by 5. So 30x minus 10y equals negative 90. And now we're just adding. Oh, darn it. So 8x plus 30x is 38x. 10y and negative 10y add to 0. 14 plus negative 90 gives us negative 76. So we divide by 38, which is going to give us negative 2 for x. We're going to take that negative 2, and we're going to plug it into one of our two equations. Okay, so I'm going to plug it into the first one. 4 times negative 2 plus 5y equals 7. So negative 8 plus 5y equals 7. Add my 8 to both sides, which is going to give me 5y equals 15. I divide by 5, and I end up with 3 for y. As always, write your ordered pair for your final answer. Hopefully you're catching on to this, making this, excuse me, as easy as you can on yourself. In number 6, if you feel comfortable, pause it, try it on your own. If you want to not pause until you see what I'm choosing to multiply by and then go from there, pause and work the rest of it out on your own, that's fine too. But I would encourage you to at least try solving some of this for yourself. Now, in cases like number 6, 3x plus 2y equals 10, 2x plus 5y equals 3. We don't have any variables where they're already the same number or they're already opposite signs. So it really doesn't matter which one you choose. I would pick the x's to eliminate because the numbers are smaller. So we're going to multiply this top one by 2 and this bottom one by 3. But one of those has to be a negative, because if it's not, they're not going to cancel out. Because remember, they have to be opposite signs. So if they're both the same sign, one of these numbers that we're multiplying by has to be a negative. Again, it doesn't matter which one you choose to make negative. I'll just say we'll multiply by a negative 3. Okay, so I'm going to multiply both of those equations. 6x, 4y, 20. And then when I multiply by negative 3, negative 6x, negative 15y, negative 9. So I add those two together. My x's add to 0. 4 plus negative 15 gives me negative 11y. 20 plus negative 9 gives me 11. I divide by my negative 11 to get negative 1 for y. And then I'm just plugging that into one of them. Again, does not matter which one. So I'm going to do the first one. 3x times 2 times negative 1 equals 10. 2 times negative 1 is negative 2. I'm going to add my 2. I'm going to divide by 3. And I get 4 for x. So I just write my ordered pair. 4, negative 1. And go from there. I hope you're catching on. If you've missed something, remember, go back, rewatch examples, try them on your own, all of that. Okay, so we're going to look at some that are going to look slightly terrible, but I'm going to help you kind of figure out a way to rewrite them so that they're not as bad. Anytime that you have decimals like in number 5, my first suggestion to you would be to get rid of those decimals. Multiply by whatever you need to do to move that decimal over as many times as you want so you have all whole numbers. So for example, we would need to move that decimal over twice so that none of those numbers had decimals anymore. So to do that, every time we move a decimal, we're multiplying by 10. So if we have to move a decimal twice, we're multiplying by 10 twice, or 100. So I'm just going to multiply both of these equations by 100 so that we don't have any decimals anymore. So that's going to give me 2x minus 5y equals negative 19. 3x plus 4y equals 52. We still have to multiply again because we don't have variables that are going to just cancel out, that are going to eliminate, but it's okay because they're whole numbers, so they're not as scary anymore. If you want to go with the fact that you have a negative 5x and a positive a negative 5y and a positive 4y, we can eliminate our y's. So I'm going to multiply the first equation by 4, the second equation by 5, which once I multiply, I'm going to have 8x minus 20y equals negative 76. And then 15x plus 20y equals 260. So I'm adding 8x plus 15x is 23x's. Negative 20y plus 20y is 0. Negative 76 plus 260 is 184. I'm going to divide by 23, which is going to give me 8 for x. And then I'm going to plug that back into one of my equations. Now, you can plug it into one of the original equations with the decimals. So we can plug it into one of these up here. I'm not going to do that because once I plug into those decimals, it makes my life more difficult because it's easier to make a mistake. I'm going to plug into one of my new equations, one of these two right here. It does not matter which one. Since the bottom one is all positive numbers, I'm just going to plug into that one. So 3 times 8 plus 4y equals 52. 3 times 8 is 24. I'm going to subtract my 24. So 4y equals 28. And then I'm going to divide by 4 to get 7 for y. So I just end up with the ordered pair 8, 7. So anytime you have decimals, multiply by multiples of 10 until they're not gonna have any more decimals. So if you have to move a decimal over one time, you're multiplying by 10. 2 times you multiply by 100. 3 times you'd multiply by 1,000, and so on. You shouldn't have to ever multiply by anything more than 100 to get rid of your decimals. 3 decimal places would just be mean and vindictive. I wouldn't expect to see something that large. Okay. Fractions take kind of the same approach. So our first equation, all whole numbers, so we don't have to change that one at all. The second equation, we have 3 halves r minus 5/4 s equals 3/4. I would suggest getting rid of the fractions. So multiply by a number that will get rid of all of those fractions. In this case, if we multiply by 4, because 2 is a factor of 4, it'll get rid of all of those fractions. And you can multiply those straight in your calculator. Like you can do 3 halves times 4, 5/4 times 4, 3/4 times 4, so that you don't feel like you have to make a mistake trying to do it in your head. But you're just going to multiply that by each one of those pieces. So my first equation is going to stay the same. 3 halves times 4, remember it's 4 over 1, so we're multiplying straight across. So 3 times 4 is 12, 2 times 1 is 2, 12 divided by 2 is going to give you 6r minus 5/4 times 4 is going to be 20 over 4, which simplifies down to 5s. And then 3 over 4 times 4 is going to simplify down to 3. So even better here is that now I have a positive 5s and a negative 5s. So I can just add those together to get 12r. 5s and negative 5s is 0. 3 plus 3 is 6. When I divide by 12, 6 over 12 just simplifies down to 1/2. And I'm going to take that 1/2 and I'm going to plug it into one of my equations. To avoid the fractions, I'm going to plug it into my first equation. So 6 times 1/2 plus 5s equals 3. 6 times 1/2 is 3. I subtract 3 on both sides. Divide by 5. 0 divided by 5 is just 0. So my ordered pair becomes 1/2 0. Okay, I really want you guys to try this one on your own, especially if you haven't really tried one on your own yet. So pause the video, try this one out, work it out, see what you get, and then hit play again and compare it to what I have. So both of these have variables that are already opposite signs, so it's kind of up to you which one you want to eliminate. I'm going to eliminate my x's since the numbers are smaller. So I'm going to multiply my first equation by 5 and my second equation by 3. So when I add those together now, negative 15x plus 15x is 0. Negative 60y plus 60y is 0. 15 plus negative 15 is 0. So much like when you ended up with something that was a true statement, like 0 equals 0, 5 equals 5, when you end up with things like that in elimination method, if they're true, it's infinitely many solutions. which remember just means that if we were to graph both of those lines, they're going to be the exact same line. If we ended up with something that was not a true statement, like let's say we had, something like negative 3x minus 12y equals 3 and 3x plus 12y equals 5. When we add those together, we get 0 on the left, but we get 8 on the right. Those would not be equal to each other, obviously, so that's when it would be no solution instead of infinitely many. So if it's true, infinitely many solutions. If it's not true, no solution. Okay, last one, word problem form. A band charges $500 to play for 4 hours plus $50 for each additional hour. A DJ charges $300 for 4 hours plus $75 for each additional hour. After how many hours will the cost of the DJ exceed the cost of the band? So when we solve this one, we are going to write the equations as if we're writing it for like a total cost. So for a band, we're saying they charge $500 for your 4 hours plus $50 for X amount of hours after that 4. We're just going to set that equal to Y. And then the DJ is going to charge $300 for 4 hours, but then $75 for each hour after that. So this one, story problems, a lot of times you don't need to solve them by elimination. I would not recommend solving this one by elimination because they're both set equal to Y. So we can just substitute them in. So I'm just going to say, okay, I'm going to substitute my 300 plus 75x in for Y in that first equation. And I'm just going to solve for x. So I'm going to subtract my 50x to get 25x. I'm going to subtract my 300, which gives me 200. And then I'm going to divide by my 25. So 200 divided by 25 is going to give me 8. So remember, our x value is how many hours. So after how many hours will the cost of the DJ exceed the cost of the band? So that DJ is going to start to cost more after hour 8. At hour 8, they're going to be the same price. So any time after 8 hours, any longer than 8 hours, it's going to make that DJ cost more than the band. That's it for this section. Your assignment is in your book. It's on page 388. 2 through 30 even. 47, 55 through 60. I'll also post that on the assignment page as well, so it'll be in multiple places. But if you have questions, let me know. Email me, Google me, whatever.